Hello guys, today we'll perform exploratory data analysis with Python and Pandas based on a very interesting topic personally to me. And this is the tip number 1. You can create your portfolio projects or any public projects based not on someone else's idea, but on something that personally interests you. So I'm a basketball fan personally, and recently I caught myself questioning about scoring in the NBA in recent years. So I saw this tweet with final result of All-Star game, which is astronomical, 200 points in one game. You're kidding me? In comparison, 20 years ago in the Shaq era, it was almost 2 times less. But of course, it's an all-star game, so I thought, is it the same score growth in regular games? And also I noticed that in the games, everyone is now shooting 3-pointers. So is it also a trend? So with exploratory data analysis with Python and Pandas, you can explore something similar that interests you. And there are a lot of data sets available on Kaggle for free, and I found this one. NBA database with scores and more data of the games starting from the year of 1946. So I downloaded that dataset and took one CSV from that. And I have also put my analysis on Kaggle. So in the code you can see this notebook, and I will link that in the description below. But basically we have 2 questions, 2 hypotheses. First, is the scoring really rising over the years? And second, does it correlate? Is it caused by 3-pointers? So do players score or shoot more 3-pointers, or maybe they got better at 3 points percentage? Let's find out together. So first, let's read the CSV with Pandas. We import Pandas and we set the option to see all the columns. Otherwise, Jupyter Notebook hides some columns and we don't want to do that. So we read the CSV. And I immediately know that the game date will be important and we need to group by that. So I immediately parse that as date to avoid parsing later and reformatting. So in total we have 65,000 rows with these columns like season ID, team home name, game date. So this one will be important. And then you don't have to be a basketball expert, but basically our main columns will be points home and then points away. And this is exactly what we'll do along the way, filter the right columns. But before filtering the columns, while looking at the data, while exploring it, I found that there is a column called season type. And for comparing apples to apples, we should exclude things like all-star games, and maybe there are other types of games. So I found out there's preseason, which is also not official. So we need to filter those out. And this is exactly what I'm doing here. I'm building DF games, a separate data frame with season types, only those 2. And now we have 64,000 rows to work with. Then columns. With dataframe.log, I'm getting all the rows, but only those columns that we need. So points home and away for the team. And then FG3 stands for field goals 3. 3-pointers basically. And then M stands for made, A stands for attempted. So made and attempted for both home team and away team. This is all we need for our analysis. We don't care about any other data. And we have game date. Unfortunately, we don't have season name. That's why I'm grouping by year of the game and not the season. This is not exactly the same, but the trend should still be clear by year. And also we see NaN values for 3-pointers in those earlier years, but we will get to that in a minute. As I said, we will be grouping by year, so we don't need the actual date, we need year. So we create a new column year, and that's why I did parse date earlier to get that year, and then we drop the game date with access equals 1, which means we're dropping the column. And this is our new data frame. Next, we don't care about home and away teams separately. We care about total score per game, both teams combined. This will go on our graph. So again, we create a separate column and then drop other columns as irrelevant. Finally, same thing for field goals 3. We care about made, attempts, and percentage of both teams combined and not separately. And now let's see why are there NaN. If we sort values by percentage, actually we do have values with numbers. So NaN means that in those years there were no 3-pointers at all yet. So this is what you will often find out with the data. The data is not ideal. some data is missing, some is incorrect, and this is another example of incorrect. For some reason, in one game, there were 2 3-pointers made, but 0 attempted. How is that possible? And then our percentage is calculated as infinity, which will break analysis and charts later. So we need to filter that out. We find out how many rows are there with that query, and apparently it's just that one. So we drop that by index and we sort the value by percentage, and now we have correct numbers. We don't have infinity anymore. So we're done with data preparation, filtering, and cleaning. Now we can actually plot some charts and see the insights. First, score by year. We group by game year and take the average mean of total score. And this is Pandas series in the form of numbers. You can already see that there are hundreds here per game and there are 200s here in the latest years. So a pretty clear trend, but let's make it a plot. So plot with the title, and here's the first kind of insight to be made. Yes, the score is growing overall from the beginning of NBA, and the score is growing in the last 10 years or so rapidly. So this can be our first insight. For example, if you're a journalist and you want to draw some infographic for an article or a title, this could be one potential title, that scoring of the team since 2010 grew massively. But also another insight is this. Apparently in the 60s and the 70s, the game was so fast that there were more points scored. Then at some point the game changed, some rules were changed, and you have to be some basketball fan to know all that history. But now we have the plot and we have something to talk about. Now we see the clear trends, and now we can make the insights that I talked about. And indeed, if we take some random 1963, scores were really 200s. And I found some Reddit thread about it, and you can Google yourself 60s NBA scoring or pace or something like that. Now, 3-pointers. For 3-pointers, we first drop those NAN values for older years and have this, which shows us that only from 1980s there were 3-pointers either introduced or calculated in the official stats. And now let's see how many 3-pointers were made per game, average per year. And again, let's make it a plot. And again, bingo, my theory was correct that the amount of 3-pointers made is rising rapidly, specifically in last 10 years with Steph Curry and other players became kind of sexy new trend. But even over the years, it's steadily, constantly rising. But it's about shots made, the successful shots. What about attempted shots? We also have that data. And the graph is almost identical. The shots attempted doesn't mean it is successful or not. That number is rising. So perhaps that is the reason of scoring, not the amount of made 3-pointers, but the amount of attempted 3-pointers. Which leads me to another hypothesis, kind of a new hypothesis along the way. So perhaps the percentage kind of stayed the same, the percentage of successful shots. And we have the data to check that. First, let's put those together on one graph in a separate data frame, which will look like this. It's a little bit unfair to compare those two on one graph because there are different numbers and different scales, but you see the trend, that these are almost identical, shots made and shots attempted. Now, in terms of percentage, see the plot. As I was saying, the percentage stopped rising after something like 1995. So it peaked and stayed at 35% on average. And here we don't analyze individual players like Steph Curry or LeBron James or whoever. We're getting all the shots by all the teams, which is enough data to make statistical conclusions from. So yeah, from that I kind of answered my own personal questions that I was curious about, but also I can give those facts to some journalists or bloggers or social media influencers, and they could create various infographics and charts like these ones, for example. Average total points per game comparing 2003, 2013, and 2023 year, for example. This would be the Pandas code for that. We create a new data frame, we group by year, we take the mean, and we have the plot with bar and title. Also, this plot is important, as you saw that already on top. And also you can create a separate table or data frame comparing 3 pointers, how many made, how many attempted, and what was the percentage, again, with a gap of 10 years each. So you create 3 different data series with averages of made attempts and percentage, and then create a new data frame with dictionary of those, and it is automatically grouped with index of game year, because game year is the same in all of those with the same amount of rows. So it all comes together nicely in this data frame and table. So yeah, this is the exploratory data analysis for NBA database, just the game CSV. On Kaggle, you may see many more tables of data. It is available as SQLite or CSV. So if you are interested in NBA, you can do your own data analysis. And if you do, please share your findings in the comments below. And if you want more examples of such data analysis with Python and Pandas, subscribe to the channel. I will shoot more videos like this one. Or if you have any ideas for what to explore and what to analyze, share your ideas as well in the comments. That's it for this time, and see you guys in other videos.